Okay. All right, linear modeling day 3. Okay, the first thing that we talked about linear modeling on Thursday and Friday of last week. Now we're going to tie in linear modeling with 2 coordinate points. So if we have 2 coordinate points, how do we find slope? How do we find the slope with 2 coordinate points? Slope formula, yes. y2 minus y1 over x2 minus x1. All right, so we're going to use our 2 points here to find slope. So we'll do 8 minus negative 2. What happens when we have 8 minus a negative? It becomes positive. Yep. So it'd be plus. And the bottom 6 minus negative 6, again, is going to become positive. So on the top, we get 10. Bottom, we get 12. If we reduce 10 over 12, what's going to be? 5 over 6. Okay, now we want to write a y equals mx plus b equation. Do we know the y-intercept? We can't just choose it. We have to find it. Can we find it easy right now? Do we see it anywhere? Do we have it? Do we have like 0 comma anything? No. Okay, remember, 0 comma some number is the y-intercept. We don't have that. We have to find that. So we're going to use point slope form. Do you guys remember point slope form? Y minus y1 equals m. Yes. Okay, so we're going to fill in what we know. We know y1 is negative 2, so that'll turn plus. Remember when we put it into the point slope form, it's the opposite sign. Our slope is 5 over 6, and our x1 is negative 6. So when we put it in, it should be plus 6. Yes?
Can we also use the other point 6 8? Can we use that too?
Yeah, you could use 6, 8. That's fine.
Okay.
Yep, however you want to do it. All right, then we want to solve for y. So we're going to distribute our 5 over 6. What's 5 6 times 6? 5. Here's why. If you do 5 over, oh, my marker's gone. If you do 5 over 6 times 6 over 1, what happens? The 6's cancel. Oops, and you're left with 5. Okay, that's why that works that way. All right, then we would subtract 2. So we have y equals 5 6x plus 3. That's our final equation. Okay, so we've done all this point slope stuff, rewrite it into y equals mx plus b form. We've done that. Okay, we did that a couple of units ago. But we're going to apply it to word problems. Okay, any questions so far? All right, down here you're just rewriting slope formula. Here, we just did that at the top. There's steps there if you need them. Okay? Kirk. Anybody named Kirk?
Kirk TV show.
On TV show.
Good old Kirk.
Good old Kirk.
Oh, you know what that reminds me of?
Just a unique name.
One of my friends, well, my parents' friends, goes to creek. A creek.
A crick.
A creek? Yeah, the guys go to the creek. Oh.
She says borscht.
I mean, my dad says worse. He also says probably instead of probably.
Probably.
Yeah, probably. Because there's 2 majors in English.
Oh, geez. So she's like, please stop. All right, let's bring it back together.
No.
All right, we're going to write 2 ordered pairs here. Okay? So we have Kirk. Kirk is driving along a long road at a constant speed. He is driving directly towards Denver. Now, if he's driving at a constant speed, what do we know about the average rate of change? It's constant, meaning the function is what type of function? Linear. Okay, so this can be written in y equals mx plus b form. So we're going to write 2 coordinate points. He knows that after 2 hours, okay, we're going to let x be hours. Okay, he is 272 miles. So y is going to be our miles. Okay, from Denver. So if we want to write coordinate points, after 2 hours, he's at 272 miles. So those correspond. Those can make 1 point. Then it says after 3.5 hours. Okay, so if it's 3.5, what would I do? 3.5. 176 miles. It says in part B, find the rate of change. How are we going to do that? Slope. Okay, you're going to find the slope. I need my calculator.
Oh.
All right, I'm getting negative 64. Do you agree?
Yeah.
Okay, any issues on finding slope there? Okay. Now let's keep moving here. Part C says write an equation for the distance d as a linear function of the number of hours h. So if we're going to write our function, what's our slope? We just found it. Negative 64h. Do we know the y-intercept, where they started? No. Can we find it? You bet we can. Okay. We're going to use point slope form again. Okay. So let's go back. I'm just going to use 2, 272 for mine. You can choose what you want to do. All right. So I have y minus 272 equals m x minus 2. So use my point, put it in point slope, and I'm going to rewrite. So I'm going to distribute my negative 64. I'm going to add my 272 over. You get the same thing as me? Did you get B is 400? Y-intercept is 400? We agree? Okay. Yeah.
Why would you put
You good?
Yeah.
Okay. Why is our rate of change negative? Why is it negative 64?
Because they're going closer to Denver.
Yeah. So they're losing miles, right? Because they wanted, this is like D is their distance from Denver. So eventually when they get to Denver, it should be 0 miles, right? That's their goal. So they're losing 64 miles every hour. Okay, that's fine. So you can write that down here. Probably should have said it better than this. Okay, as they get closer to Denver, they're losing miles. However you want to say that. How far did he start from Denver? How far did he start from Denver? 400 miles. 400 miles is our y-intercept. When we talk about y-intercept, we always talk about that being like the initial value or the starting point, something like that, yes? Okay, so if we're talking about his miles from Denver, that's where he started, okay? He's 400 miles from Denver. After how many hours will he arrive in Denver? So what do we need to do if we want him to arrive in Denver? If we want to know when? Yeah. Plug in 0 for what? So H is hours. That would be 0 hours. That would be his starting time. Plug it in for Y, because we want his miles from Denver to be 0. That means he's in Denver. Okay, then you can solve for H. I'm going to let you solve for H. I'm going to do that part. I'm getting 6.25 hours. Do you agree? Okay, now, is that 6 hours and 25 minutes? No. You're going to figure out how far that is, okay? We know it's 6 hours. How do we find what 0.25 of an hour is?
You multiply 0.25 times 60.
Yes, why?
Because there's 60 minutes.
60 minutes in an hour. So we're going to do 60 times 0.25, and that'll tell us how many minutes.
I'm too smart. I thought you said it would be
15. Okay? So that means that it took him 6 hours and 15 minutes. To get there. Yeah.
So how does that I mean it does say hours, but you also put in the minutes, or you just put in the hours?
Well, you would tell me 6 hours and 2 minutes. If you just left it at 6.25 hours, I'd probably take that point. Okay. And here's why. I know that you have the correct answer, but interpreting it into a real life scenario, that's what I'm more interested in. Does that make sense? All right, let's keep moving. And we're going to get a lot of practice on this stuff. So, example 2, we have Amanda. Okay, she's walking away from a light pole at a rate of 4 feet per second. Let's stop there. If she's walking at a rate of 4 feet per second, tell me what that is in terms of an equation. That's a slope, right? It's something that's constantly happening. So this is going to be our slope. And she starts at a distance of 6 feet from the light pole. If she starts, the word start, initial, okay? Initial, starting point, whatever. Okay, there's a lot of different words we can use there. But because she starts at a distance, this is our y-intercept. So which equation would match up here? Yep, y equals 4x plus 6. That corresponds to number 1. That's like a prime, that's like definitely an OST question.
Really?
Yep.
That was simple.
Good. Some of them are. Some of them are. Got your question? Sure. All right. Water is draining out of a bathtub. Okay, I'm sure you've experienced this before, right? Or a tub full of water. Maybe it's like a kiddie pool, whatever. Okay? Such that the volume still left gallons is shown as a function of the number of minutes. So it says calculate the average rate of change of gallons over the interval from 0 to 2. So if we have 0 to 2, those are our x values. We're going to fill those into a coordinate point, 0 and 2. Now, what y value corresponds to my x value of 0? 62. Okay, and 2 corresponds to 28. Go ahead and find the slope. Okay, go ahead and do B if you get done with A. Agree with my numbers? If you agree.
Yeah.
Negative 17 and negative 8.
Yep.
What does it mean if we get two different rates of change? What does that mean if we get two different rates of change? It's not linear. The bathtub is not draining at a constant rate. Sometimes it might go faster, sometimes it might go slower. Any questions on that? Okay. These word colors really aren't that bad, right? Okay, example 4. The cost C in dollars of running a factory that produces staplers can be modeled by the linear function. Now, let's get this straight. This is the cost of running the factory. This is not the cost of buying staplers, okay? This is the cost of making them. Does that make sense? Like if you worked at a factory, if you owned a stapler making factory, this is what you would pay to make staples. Yes? Okay. How do you interpret C of 100 equals 2300? Let's first break this down. Okay? If we look here, what does S represent? Okay? So, number of staplers. Okay, and then what does this 2300 mean? Like what is C? The cost. Okay, and I'm going to add to that, it's the cost to make that many staplers. Yes? Okay, so can we agree that the cost of making 100 staplers is $2,300? Does that make sense? Okay. So we'll say it costs, so you know what, so you guys can see this. I need to do this more often. It costs $2,300 to, did I type it wrong? Oh. Did I have staples and I changed the staplers? There, that's easier to read than my handwriting. All right, give a physical interpretation for the two parameters in the equation. That is straight up OST type wording, right? Would I ever type something like that?
No.
Okay, so I took that straight from OST, okay? Give a physical interpretation, meaning tell me, what does the 1.25 and the 2175 mean? Okay, that's what that means. So if we're talking about cost to make staplers, not staples, what does that 1.25 mean? You're multiplying that by the number of staplers. Cost per staplers. So we can probably guess that that is the materials. Yes? Would you guess that that's like the materials to make the stapler? Yeah.
Oh, are you ready for
Not yet, not yet. Okay. So let's go ahead and I'm gonna go ahead and type that in. Ugh. Okay, so that's the cost to make each stapler. And then the 2175, what is that? Think about it. What's 2175? Like, why would they have that in their cost? I'll say it out loud. Think about it for a second. What do you think?
starting price? It's not like starting this price statement, but starting price that they have.
Okay, a starting price that they have. What else? What adds to that?
Maybe it's like the machinery they use, like that's how much they
Cost for machinery. Okay.
That's what I was gonna say.
Cost of machinery. Okay. What else? Yeah.
You said it's per sulfur and it's like the material, but then doesn't mean it goes running with that.
running the factory. Okay, so I'm gonna put all these together and say equipment costs and labor. Right? They have to pay the people who are working it. Yes? Do you agree with that? You're so quiet today. Do you agree with that?
Yes.
Okay. Hey, that's what I like to hear. All right. So cost of what did we say? Machinery
Yeah.
and labor. Did I spell machinery right?
Yes.
Wonderful.
We're not language experts here. We're here for
That's right. We're here for that. Okay. Good deal. All right. You're on to practice. Go ahead and do the practice. Okay. You're working on that. Huh? It's getting longer too. I cut my hair off last year and I regretted it. Now it's growing back. So I like it when it's really long. Mine was really long. I'm like, you know what?
like how long?
I'm chopping it. It was like down here.
Oh.
And I was like, yeah. Because I used to have like really short hair. I love having short hair. I chopped it and I was like, crap.
I just feel like
Let me glue it back on.
so when you have long hair, you want short, and you have short hair. You want
It's true. It's
That's
true.
just
But now I think that I'll really appreciate my long hair because I cut it off and I
I would get this
So now it's out.
I don't know if I should go I kind of like it, but I like my hair longer, and I would be scared. My mom was like, you should get it cut short, Olivia. I got your hair short.
Oh yeah, you said it was the same.
Stop! My bangs, yeah, I love my bangs were so ugly. I was like,
All right, get to work on your practice, guys. Get to work on your practice.
I'm excited to get myself. I'm excited in fifth grade, and they stayed up. They said something, you know. I'm just not even my tables had already done the iPhone. What the hell was that? Who told me that you did? Oh my gosh. No, it wasn't. It was I have an iPhone. I got my
It's like $1,000 for You ever seen Supreme? That's even more expensive. It's like one for like a couple.
No, it was sticking out.
But $400 for a chef. It's this big.
Is it, would it be municipal?
All right, John, get to work on that practice. I gotta make sure you know what you're doing.
I know. I know. Evan like that. I think it's like Ivan or something. You said Ivan. Ivan is here. I love that book. Right? Like, I don't think that's so weird. Oh my god, and only Ivan. This one's Jocelyn was like Jay.
Oh, okay.
I mean, with the
Friends, I'll give you a question. All of your equations are going to be written in y equals mx plus b form. Sometimes you may have to use point slope form to get there, though. Okay, that's what we did today. So you're going to write it in y equals mx plus b, but you might have to use point slope to get there.
Are you still recording? I don't know. And that's I don't like it. Hours. I just like
Time will happen, and if there's ever time will forget.
and that's okay. Well, I think that's a good